Welcome to Serverless Sorcery, where we unravel the mysteries of generative AI in the serverless world. I'm your host, Ronaldo Gunesberto, and in this episode, we'll explore how cutting-edge technologies within AI, like prompt engineering, re- retrieval augmented generation, vector databases, and multi-stage flows, can be achieved with a much simpler way than most people think. And we're going to be examining some of these workflows with Sandeep. So, we're going to be diving into a topic which is inspired by Einstein's words: if you can't explain it simply, you don't explain it well enough. We're going to break down these concepts and prove that they're only tricky because they haven't been explained right until now. So, without further ado, I'd just like to welcome Sandeep to the stage to talk to us through it as well. So, Sandeep, how are you doing?
Doing great, Ronald. Glad to be here. How are you?
I'm great. I'm great. Thank you for asking. So, Sandeep, do you want to tell our guests what we're going to be speaking about today?
Yeah. So, like you introduced it, there are concepts like RAG, vector databases, prompt flows, all these things which have been complicated over time. So, what we're going to do is we're going to take an application that we use internally and see the different levels in which we integrated an AI to it and simplify the entire all these concepts.
Great. Sounds great, Sandeep. So, yeah, we have a really action packed episode for all our listeners today. Pretty much, let's get started as well with a bit more talk as well about uh, vector databases. So, Sandeep, been your own experiences so far with vector DBs, and how have you been finding it?
Yeah, so I started off like everybody else by looking into Pinecone and other databases, but I found the concept to be really complicated. But then I came across Amazon Bedrock's knowledge base, which is way more easier to use, and same with other partners like Elastic. So the entire idea is that nowadays the applications that are coming out with a very easy way of using it. So you just need like 5 to 10 minutes to connect to a data source, and it does all the embeddings, and you can directly start asking questions on top of it. So the way the industry is heading, I think it's just going to get more easier for everybody to start using like the databases.
Definitely. I feel like vector databases certainly has been made much easier as well from uh, AWS sense of view, especially when it comes to utilizing RAG. I feel it's been
Yep.
great to see it for a lot for beginners, especially since a lot of the options come predetermined as well. You can pretty much just spin up some RAG and automatically get an OpenSearch connected to it as well, which I think is a very great start as well. And
Yep.
I know that you currently also have, you run pretty much a bit of work as well for Feedbackly too. But you want to talk a bit more as well about how you've been using vector DBs for getting better AI insights as well in terms of that too, and a bit of your work on Amazon Bedrock for in regards to that as well.
Right. So the first thing about Bedrock is before I started using Bedrock, the entire concept of RAG was pretty confusing, mainly because the way it has been put out, right? The content to consume is too high. But then once I started using Bedrock, that's when I saw it in action. And then I started realizing, oh, this is what exactly RAG means. And these are the embeddings, and this is how the entire flow works. Right? So it just made that entire domain so much easier to understand and get started with, right? And then when it comes to Bedrock, you just need to connect a simple data source. So in our case, we use S3, but theoretically, you can use any data source. And once we started playing around with vector databases, we started looking at the different options and how it queries the data, how it retrieves the data, and what exactly RAG means, right? So some of the simple use cases we have dealt with are sentiment analysis. So we have a particular content and we need to analyze the sentiment or derive some types of inputs out of that and store that in a vector DB and then run a query on top of it, right? But then the complex use cases get when you start using images, when you start using PDFs, or when you start using video files, things like that. So then the parsing of these documents becomes a little more complex, and then you store them in the DB, in the vector database. And then you need to get really smart about how you're querying them. You cannot dump the entire database and run the query on top of it. You need to classify the data into different categories of what you're looking for. So that way, I think you start off with something pretty simple, but then you start classifying the data. And the cleaner your data is, the faster your retrieval is as well.
Definitely. It's certainly a great addition, I feel, to our listeners as well, especially in regards to getting those more utilized. And I think the really, for me, the most powerful thing is just really always it really strengthens what you currently have from those third party models too. I feel because you pretty much get up to date insights based on your own knowledge, based on your own real world feedback as well, which I think is a really great thing. And I think it's a great segue as well to pretty much also talk about how these flows as well can be also used within agents. Now, I know you've also
Yep,
mentioned as well before that you also have worked with agents as well previously, but
correct.
how's your experience been with agents been so far?
Yeah, so I've been big on serverless. I've been building serverless applications for the last 5.5, 6 years. And the current company I work at, Anstack, is purely serverless focused. Like we build only serverless applications. So that being the case, uh, always wanted to make sure or always wanted to plug in serverless into the RAG spectrum of things. And that's where the Bedrock agents come into picture. So with the Bedrock agents, you can configure a Lambda to be run on a particular instance. Like, for example, we'll talk more about it in our use case, but you can do LLM interception. So, for example, you create an agent, you tell it a set of instructions, and you configure some lambdas to it. And now, based on your instruction, it is going to invoke the lambda. Now, this lambda is again going to get the inputs of what the user has queried, what the LLM has processed so far. With all this information, you can write custom logic within your lambda and then parse it back or send it as an output to this LLM, which can do the next set of tasks. So that's where agent really plays out. So some of the things that the code cannot analyze can be analyzed by the LLM, and then you use the code to do the additional functionalities that you're looking for. And again, Bedrock Agents has made it so much more simpler. You just need to configure the right prompt to it, and all the rest of it is taken care of.
Definitely. I agree. It's certainly a game changer for a lot of different tasks, especially because you need to automate a lot of different processes. And especially for decision making, it's really a game changer. So I feel like it's really been great to see how it's been used in the serverless world as well. Don't you think? Like it's been used for getting more insights, getting more recommendations, and I think it's a really great thing, especially when you combine it with different things like step functions and just a different way of being able to automate the processes.
Yeah, I think when you look at it from a serverless world perspective, at the end of the day, you're calling an LLM through an API. So at the end, it's just another API integration as far as serverless is concerned. So it really boils down to what exactly is the use case and how creative you're going to get with the solution. And one thing to always remember is to not to over engineer things. So we always get caught up in this situation where just because the industry is using RAG and vector databases, now even I have to implement that. But that's not always the case. Simple engineering solutions can solve the problems. That's also part of what we are trying to coach.
Definitely. I couldn't agree more. I feel like that's the thing as well with what a lot of people think of when they think about working with Bedrock or other LLM processes as well on AWS. It's always, you have to architect these complex solutions. You have to try to make sure that it is connected with, integrated with your app as nicely as possible. But really, it's just a matter of utilizing it. And, it's just matter of like simple API calls pretty much made as well. And that's also why Bedrock is there because you're meant to pretty much just get it through one unified API and pretty much just make calls based on that. So it's a really great
Yep.
way of being able to do it. And I think using agents particularly has been like a really good way of being able to do that. Is there anything else that you think would be interesting as well from a feedbackly perspective as well? Do you think from using Bedrock agents as well? You'd like to share too?
Yeah. So one thing I've realized by working, like from the time ChatGPT was announced, we have all, been getting our hands dirty on AI, LLMs, and things like that. One thing that LLM really shines on is at making subjective decisions, right? So you have a particular statement and you need to find the sentiment out of it. So that's especially where LLM shines out because when you put a user or a manual person to it, then you start getting into objectivizing it, right? So you have your own context before you're even reading out what it is. So you're not able to classify it properly. But then if you're passing that data to an LLM, It's a system which is going to process irrespective of emotions, right? So that's where LLM shines out. And I think that's also part of what we're trying to say in the Feedbackly application.
Couldn't agree more, Sandeep. I think that's a really great point to make. And I feel like a crucial part of what we really also wanted to talk about was in regards to multi-stage flows in particular.
Right.
And I understand that it's also relatively, we haven't talked about multi-stage flows actually yet within the podcast episode. Sandeep, do you want to explain a bit more as well about, in your own definition, and what multi-stage flows are and why they're complex
Yeah.
within our complex AI workflows?
So I like to call it divide and conquer. So the basic idea is instead of having one single prompt and one single API call to an LLM, which is processing all the things that you need to do, you break it down into individual smaller bits of it and use your code as much as possible. So instead of one single prompt, you break it down to a smaller prompt, which does the initial analysis. Then it goes into a code that executes and identifies what needs to be done, what data needs to be updated. Then it goes to a different stage where again, it could be an LLM, it could be querying the database and anything of that sort, right? So traditionally, if you look at how the technology has evolved, we have been going from a monolith based architecture to a distributed architecture, mainly because it simplifies how we are dealing with things. You have a smaller blast radius and so many other functionalities that it provides, right? So even with the LLM world, I think we are heading into a space where people are moving out from an individual, a large bulky prompt to separated out multiple stage flows, which are again orchestrated by something like step functions, or Bedrock has this functionality called prompt flows. So there are different ways to orchestrate it. But the idea is you split it out, you have individual control over these components, and you make them more precise as you go forward.
Definitely. I feel like it's a really great way of approaching this kind of problem too, especially when you work with different flows and you work with different uh, LLMs as well within the Bedrock ecosystem. I feel like with when you look at automating different processes and different ways of doing things, it certainly makes sense to uh, look at this in that direction of trying to split it up and trying to apply it in different aspects. So can you walk us a bit through as well more on how you've used it as well alongside the different processes within AWS as well, and how have you used multi-stage flows particularly? Maybe you've used like Lambdas as well as part of this. Maybe you've used a Bedrock as part of this too. Like how have you used it?
Yeah, so I'll take it from the start. So Anstack is a company that builds serverless applications. So we take care of the application from the end to end, meaning from the design to front end, back end. We also have a separate machine learning division. And of course, we also have an AI division. So given the nature of our business, at any given point in time, we have multiple projects running with different clients. Now, all of these projects again have different sprint schedules and whatnot, right? Now, the way we were collecting the sprint feedbacks was not efficient. So each of us had our own way of collecting the data. So it was completely spread out. Some of them collected in Google Sheets, some of them in Jira, and so on, right? So this data was completely distributed. So we thought first, let's build an app for it where you log in, you see all the feedback that you have received, right? So just a feedback collection system. And that's when Feedbackly as a concept came into it. Now, the other problem we had is that nobody likes to give bad ratings. I don't know what's the reason behind it, but any developer I've spoken to within the organization, outside the organization, nobody wants to tell you anything negative. And every time we added a scale, rate this person from 0 to 10, it was always 10 or 9. So when we built Feedbackly, we also wanted to make sure that this problem, is overcome. So what we did, instead of asking the user to provide the rating, we asked the user to give a descriptive feedback. So the user could provide something like, this person has been doing good, their code quality has been great, XYZ. Now, we take that feedback as a comment and send it to an LLM and ask it to classify this against three parameters that we can measure. So internally, we use these parameters called productivity, positive energy, and reliability. Now, based on the comment, the LLM is going to process the information, process the comment, and tell us or give us a rating from 0 to 5 on these three parameters. And that we would store it in the database. So, to see whether it is working or not, First, we designed a simple prompt. Now, the simple prompt just says, I need you to classify a feedback that I'm going to give. You need to rate it from 1 to 5, and these are the three metrics on which you need to rate. Now, to test it out, Amazon Bedrock. So, firstly, Amazon Bedrock is basically an LLM house, right? So, it has integrations with different LLM vendors, Anthropic, Meta, Claude, all these LLMs and providers, right? And it provides you playgrounds in which you can test and play around with these prompts. Now, we use the chat playground. So when you use the chat playground, it allows you to run the same prompt against different LLMs and visualize them in the same screen. So then you can identify which which LLM is working out for you, which is not. And another nice thing about this chat prompt is that it gives you the model metrics. It tells you how much input tokens you're consuming, how much output tokens you're consuming, what is the time it took for the LLM to process the query. Now, with all this in place, we started calculating how much token usage will we be doing for X number of feedbacks, and what is the time we are looking at for this API to complete its transaction. So this was the first part. So we tested it out, and the idea is working. We provide a feedback, the LLM will process, and it is rating out the feedbacks. Now that gets stored into the database, right? So the next part comes. This is where we enter prompt engineering. So prompt engineering is basically a process to make sure your prompt always delivers the results that you're looking for. Now, the simple prompt, although it works, when you provide uncertain feedback, it is going to break, right? So the LLM output is it's just going to say, I cannot process the request and things like that. So it will start hallucinating when you don't tell it what it needs to do. So when you come to prompt engineering, there are a few basic rules that you need to follow. So first, you start with a persona. So you tell the LLM what it needs to do. In our case, the LLM's role or persona is that it is a feedback evaluator, and it needs to rate the feedback on these three particular metrics that we are looking for. Then we provide action. So action is just a set of instructions on what exactly it has to do. So now in our case, we are telling it to take the feedback, don't take any emotional aspect of it. Now rate it based on these three factors that we're looking for. Then you also need to provide reference cases, positive cases, negative cases. So this will help the LLM understand what it needs to do when it's not able to evaluate the factors. So for example, if a person has provided a feedback and that doesn't have any aspect of say reliability, what does the LLM need to do? If you don't tell or if you don't provide the negative cases, the system will break. So we provide a negative case telling. If you are not able to classify it, give it a -1 rating. And in the comment section, you also let us know why you're not able to classify it. So that we again send it back to the user and let them know the feedback is not complete because it's lacking this aspect, right? Next comes the variable aspect of it. So this is where I think Bedrock is a differentiator compared to how we were doing it before. So ideally, in cases like this, what you would do is you would have the prompt stored as part of a variable in your code. And when you want to insert some specific aspects of it, like in our case, the feedback keeps changing. So you want to insert feedback at a particular place. You would do a string concatenation and things like that. But when you're using Bedrock's prompt management, you can pass them as variables to the API calls that you're making. So you don't have to send the prompt all the time. You just have to send out these variables, which just makes the entire code much cleaner than what we traditionally do. Next, you have the output format. Now, once you tell the LLM what it needs to do, you also need to define how you want the output. In our case, we're telling it to provide in this specific structure. It needs to be a JSON. It needs to have these keywords. The values need to be a number and so on, right? So you need to tell or define clearly what it needs to do. So this is what prompt engineering is. These 5 sets of things: a persona, an action, positive cases, negative cases, variables, and output. So with this, you create or you construct a precise prompt which always works irrespective of the data that you're providing to it. Now, with Amazon Bedrock, you have a prompt management section where you can test out prompts against different use cases as well. Now, you can compare different versions of the prompt parallelly and see what is the output it's getting. Now, again, you can configure these variations on the same LLM on different LLMs. That's left to our use case, right? So what we did was we have one section called be stringent with the ratings. It's part of the actions. And we tested it with another prompt which says be lenient with the ratings. And then we compare the outputs. So over time, what we did is we kept changing these parameters again and again to see what kind of outputs we are getting, and also to keep the system active. Because if you keep the same prompt, the users will eventually figure out how to break the system. Users will know, if I give this feedback, I'm going to get this output. So to keep it lively and to make sure this condition is avoided, we started modifying the prompts every once in a month, once in 2 months, at a particular frequency. Now, with all this in picture, we integrated that to the application. We provided a text area where the user can provide the comment, or they can also provide audio recording, and that is converted to text. We call the same API and get the result. All this was working well, and a couple of months go by, and we have data from all our engineers. Now, what do we do with this data? Can we make something meaningful out of it? So that's when we started exploring vector databases, and that's when we started getting deeper into RAG. Now, before I get into the vector database offerings of Amazon Bedrock, let's just go through some of the basics of what a vector DB and what a RAG is. Now, the first thing is the vector. A vector is basically a mathematical representation of the data that you're providing. So it's an array of numbers. Essentially, that's what it is. And what is a dimension? So let's take an example of a fruit. If you take apple, and you have different properties like color, sweetness, sourness, and the shelf life, for example. So these are the different properties. Now, when that is converted to a vector, each of this property becomes a dimension. And that is what is essentially a dimension. It is the property of the data that you're providing. Now, this is a simple example, but of course, in a real life use case, it's much more complex than that. And then you have indexes when it comes to vector databases. So indexes are how a vector database knows what it has to search based on the question you're asking. So let's say Apple is an index and orange is an index, and you're running a query, then it will search on these two indexes and provide the result that you're looking for. Then comes the embedding part. Before you're able to search something on the vector database, you need to convert your data into vectors and store it. That's exactly what embedding is. So you use an LLM, send it the data, it converts them into vectors on all these dimensions. It splits the data on all the dimensions and stores it in the database. This is what embedding is. Now coming to the final part, which is RAG. So when you ask a query, like list some red colored fruits, right? So what it does, it goes to an LLM. Now this LLM converts or identifies what you're trying to ask. In our case, we are asking for fruits that are colored red. So red is one of the property and the dimension is the color, right? So all this data is calculated by the LLM, and then it creates them as a vector and then sends it to the vector database. Now, the vector database, upon receiving this vectorized information, it is going to query on the indexes that it has created, right? Then it will provide the result. The fruit you're looking for is apple. And because it's vectorized, it's going to also retrieve the nearest matching members as well. So if you have apple and if you have something that's also red or close to red and which has a particular number to it, it's going to retrieve them and rank them in that particular order. So this is what RAG is. Your input is converted into a vector. That vector is searched against the database and your top results are provided. Now, coming to Amazon's Bedrock. So Bedrock has an entity called knowledge base. So they have two variations of it. So one of the variations which is straightforward to use is chat with document. You just upload a document that you're looking for, and then you start asking questions on top of it. This is in case you just want to test out how it works, or you want to test out with a particular document. But when you want to test out with your own data, then you create an actual knowledge base entity. Now, in the actual knowledge base, first you configure your data source. You can configure S3, Jira, and there are, I think, 4 to 5 other different data sources that you can configure. For our use case in Feedbackly, we chose S3. So what we did is we took the data from DynamoDB, we exported it as to S3, and we provided that S3 bucket as a source for the vector database. Now, coming to the next step of configuring your data source, you can select your parsing strategy and chunking strategy. What it means, parsing strategy is used when you want to customize the way the LLM is processing or creating the vectors. So ideally, when you're using any kind of text, you don't need to configure anything additional, the default mechanism works. But if you're using something like a video or a PDF image and things like that, then you will have to choose a parsing strategy where you can configure another LLM to do all this processing that you're looking for. Then you have chunking strategy. So when you're storing something in your vector DB, you're storing chunks, meaning you're storing subset of your data. Now, there are different ways you can there are different ways you can split your data, and that is what chunking means. In our case, we used the default chunking where each file becomes a particular source. That did not work out. So then we tried with no chunking strategy, which worked out for us. So for every application that you're looking for, you need to have a control, or you need to have a say on what kind of chunking works for you. You can experiment this and find out, or you can try it out in the console and find out. Another beauty of Bedrock is it allows you to involve a Lambda function in your chunking. So let's say the default options provided by Bedrock doesn't satisfy the requirement. You can invoke a Lambda for your chunking strategy and customize the chunking based on the application's needs. Then you go to the next step where you select the embedding model, which does the conversion. So there are about 3 to 4 options that are available from Bedrock. And then you select the vector database where this data needs to be stored. Now, the quick create option creates an Amazon open search and creates the collection for you, and it stores the data over there. But there are also other options that you can choose from. Now, after you create the database, you select what kind of chunking, parsing, all this configuration is done. Then you can go to the knowledge base console and start running queries on top of it. So you have different query options when you select the knowledge base. You can do a semantic search, which is basically a vector search, or you can select a semantic and text search, which is a hybrid search. So that way, it is going to search based on the text that you're providing and also on the vector that it creates. You can also configure the number of chunks you want to retrieve. This is where it plays a major part. Now, based on your application, you need to determine how much of data you want as an output. And then you also need to select the number of chunks. So all this is pretty important, and it changes from application to application. So just play around with the settings and identify what works best in your application case. Another good thing about knowledge base is that you're able to provide a custom prompt to your knowledge base. So in case you want to modify or you want to instruct the LLM on how it needs to search for the vectors, you can mention that as a prompt in the knowledge base console. Now, with all this configuration done, we started asking queries to the knowledge base, like this is the email ID, say sandeep@einstack.io, and the queries looks something like, can you summarize my top 3 feedbacks? Now that queries a LLM, queries the vector database, and gets the top results and summarize the results. Now you can also ask questions like, mention my points of improvement, right? So then it queries the feedback which has partially negative feedbacks and then summarizes and tells what are the things that I'm doing good and what are the things I need to do better. Now, with this, we enable chatbot to all our admin users. Now, at this point, there was a problem. We wanted to enable it to all our users, but then the problem is that when we run a query against the knowledge base, it gives the result irrespective of who's asking the question. So as an admin, I can ask questions about anybody else, right? My mentees or any other employee. But as a regular user, I should not be able to query somebody else's feedback, or I should not be able to summarize the feedbacks of somebody else. So that's when we started exploring agents. Now, Amazon Bedrock also has the concept of agents where you can configure different things. So what we wanted to achieve is when a regular user asks a question, they should be able to ask a question only about themselves and their feedbacks. But if it's an admin user, they should be able to ask questions about anybody else in the company. So that's when we started using agents. Now, in agents, the first thing you do is you write a prompt. Now, our prompt, the basic functionality is you are going to identify who's asking the request and for whom they're asking the request. And you're going to create a variable called query type. And the value of query type is going to be self or others, right? And then we send that to an action group. An action group is where you create a Lambda. Now, this Lambda is going to get an input of query type, which is going to be self for others, right? Then it is going to query a different database like a DynamoDB and fetch the list of admin users. Then it's going to see if this user is, if they're asking a question about others, are they part of the admin group or not? If they're part of the admin group, it simply returns a variable called next and it says continue. If they're not part of the admin group, it says end, right? So the main prompt that is configured in the agent is created in a way that it can identify the output and then call the knowledge base or choose not to call the knowledge base based on the result that the Lambda is providing, right? So as part of the agent, you create an action group. An action group is where you configure your Lambda. And when you're configuring the Lambda, you can provide the input parameters. So in our case, we are providing the query, the email, and the query type as part of the input parameters, which is then received by the Lambda and processed. Now, as part of an agent in Bedrock, you can also create the knowledge base. Now, we have already created the knowledge base previously, so we can tag that over here. So our agent has an action group, which is a Lambda and a knowledge base. So based on the results of the agent, it is going to query the knowledge base or not query the knowledge base. Now, once all this configuration was done, we started testing it out. So when we ask a question, say the email is random at Einstein, and we ask a question, summarize Sandeep's feedback, it is going to throw an error telling you are not authorized to make this request. Contact your administrator. But when we ask a question about myself, so Sandeep at Einstein.io is my email, and the query is summarize Sandeep's feedback. When that is queried, the action group will succeed, and then the LLM will query the knowledge base and provide the results that I'm looking for. Now, once this part was done, we integrated this to the application as well, and then all the users had access to the chatbot. So this was going well for a while, and then we wanted to see if we can take it one step further. So what are the other things that we can do with this data now that we know it can point the users into a right direction on how they need to improve their career? So that's when we got the idea of integrating all the data about a user. So internally at Anstack, we follow the role sequence called member of technical staff. So it goes from MTS 1, 2, 3, 4, and 5. So what we did is we stored the information of our MTS expectations. So what is expected from an MTS 1 member? What is expected from MTS 2 at 3, 4, and 5? And if a person needs to go from MTS 1 to MTS 2, they need to satisfy these criteria. For example, MTS 1 needs some kind of hand holding when they're working on that task, but MTS 2, you should not be having any hand holding. That you should start mentoring other MTS 1, right? So some of these criteria we input it to the system. And then we started using prompt flows to see if we can chain all these things together and get the results that we're looking for. Now, prompt flows is another entity of Bedrock, which allows you to create or orchestrate prompt, Bedrock agents, the other agents that you have created, Lambdas, upload retrieval, and there are also logical blocks like conditional blocks, compare blocks. So all these things in a drag and drop interface is prompt flow, right? So our flow does the following. So first we have a simple prompt which identifies whether the query is for themselves or for other people. Once that is identified, we send that to a Lambda. That Lambda queries the admin list of users and tells if this person is allowed to make the query or not. Then that output is sent to a conditional block, which checks what is the output and then allows or denies the request going forward. If it denies the request, the user gets a message unauthorized. But if it allows the request, it goes to the next prompt. So this prompt is specifically designed to classify what kind of query it is, whether it is a career related question or whether it's a feedback related question. Now, if it's a feedback related question, the next entity we call is the knowledge base, get the feedback, summarize it, give it to the user. If the question is about a career, then we still query the knowledge base because we need that information as well. But then we have an additional step which invokes a Lambda. This Lambda is now going to pull out the information about the MTS specifications and also the current skills of the user making the query. With all this information, we call the final prompt, which does the summarization, identification, everything. This prompt is designed to collate all the data that we are passing to it, identify the question, the context, the relevancy, and provide the user with the relevant output. Now, when we tried this out, uh, when we asked query about the feedback, it was working as before itself. Like when we were using agents and when we asked it to summarize, the same way, the same logic is applied, so it works perfectly. Now, when we ask a question about a career, like how can I improve my career? What are my setbacks? Right? Now, it collates all this information and tells you your strengths. These are the things that you're doing good based on the feedback and your NTS expectations, whether you're matching them or not. It tells you the areas to improve. If you receive any negative comments or marginally negative comments, it identifies that and tells you the users are telling or your peers are telling that these are the things you're not doing great. Now you need to improve this. And then it tells you what you need to do to go from MTS 1 to MTS 2. It collects this information and tells you these are the things you're doing right and these are the things you're doing wrong. Now, if you satisfy these particular criteria, you'll get the promotion that you're looking for. And when you ask questions like, what are my setbacks? It is going to go through all the information or all the comments that you have received. And it is going to tell you what are setbacks, if you have any, or if you have not received that much of a negative feedback, it's going to tell you that you don't have any setbacks as of now. So with all this information, we are giving the control back to the employees that they can query and ask whether they are going to go from MTS 1 to MTS 2 or what they need to do to improve in their career. So the entire application went from just storing the feedbacks to be able to decide where your career is heading towards. Yeah.
That's great, Sandeep. I think it's a really important thing, especially in feedback. I know how hard it is, particularly when you're asked to give feedback of other people, and pretty much like you just want to be a decent person, right? You don't want to you don't want to like give
Exactly.
bad
That's
feedback
the
to
problem.
people, and yeah, and exactly like that is the main thing. So being able to collate information and being able to make Sarah's recommendations actually means so much more to a lot of people actually than a lot of people think, because well they need that feedback, they need that to like get to the next step of their career. So it's a really great thing that you implemented. And I think this implementation of the within the AWS ecosystem within the multi flows is a really great way of being able to do this, and I really like that implementation. I just wanted to zoom in a bit more as well when you mentioned as well that you change prompts once in a while, as well as you mentioned before too. When
Yep.
you mentioned that, how do you decide like the frequency of changing the prompts, and how do you decide what prompts particularly do you want to change to? Like every time you change, like do you experiment with it first, or how do you do it?
Yeah. So there are two things that we do. First thing is we keep checking the feedback regularly as admin and as a chief of staff. So we keep checking to see if everything is going good. And if a particular project or if a particular team again has 10 on 10 ratings or 5 on 5 ratings for quite some time, then we know something is, something. So they're doing something great or something is we are missing out, right? Then we go and change the prompt, modify the prompt. Now we change only one particular part of the prompt where it says be strict, be lenient, and we add different clauses to it. So you check for these parameters and then give the output based on that. Again, to do that, we use the compare prompts option, which is there as part of the prompt management console. So the same feedback we can test against different variations of the prompt and see which one is working and which one is not, and whether the new prompt or the new addition that we're doing, whether it's breaking the system or it's working as expected. And once that is done, we push the changes and go through the entire cycle of it again.
Definitely. That's a really great approach to it. And the other thing I really wanted to ask as well, more too, based on your story, is I think a lot of our viewers, a lot of viewers are not really too familiar as well, probably with the chunking strategies. And I really like that you mentioned a lot in regards to how you're currently also chunking the data as well, that's really flowing through as well. Can you talk a bit
Mhm.
more as well about how you designed your chunking strategy and how you decided to particularly make it the way it is as well?
Right. So when we started off, we just had one single file which had all the data from exported out of DynamoDB. Now we gave that as the input to knowledge base, and we gave the default parsing. And when we asked the question, it gave beautiful results. The summarization was amazing. But then when we looked at the data sources, it was just pulling out random information which was not related to the user because it's one single file, right? So the LLM does not know, or the vector database does not know what it needs to search on. So whatever it finds relevant, it was providing it. And that's when we understood you need to chunk it out, or you need to separate out the bits properly, right? Then what we started doing is we started separating out the feedbacks based on email IDs, based on their average rating, based on what type of feedback it is, whether it's a positive feedback, negative feedback. Then after separating out these files, we gave it again to the vector database. But this time we selected no chunking. So when you select no chunking as part of your strategy, it will consider your files as a whole chunk. So every JSON file we gave it is considered as an entire chunk of data. Now, when we query something based on the user, it knows the intent of the query and it pulls out only that particular file, and then it checks what are the relevant comments and processes only that. So that's where chunking actually comes in. So you need to separate it out enough for the LLM to understand what it needs to query. But at the same time, you cannot have it too fine grained that you need to get a lot of data out of the system to process something. Now, the other part where the chunking affects is based on the LLM that you're using. So every LLM has a limitation on how much input it can consume. So if you have very large chunks and you provide it to the LLM, it will start hallucinating with that data. The cleaner, the more precise or concise your data is, the better an LLM performs. And that is where you need to test out with different variations of your data, different chunk sizes of your data, and see which part is giving you most accurate results.
Right. And I think to support that as well, I feel like that's also why it's very important to have a proper evaluation measures as well in place, especially making use of Bedrock's evaluation tools, making sure that the models are properly evaluated, and also to make sure that there are, well, potentially using also Bedrock's guardrails as well as part of also preventing some potential hallucinations or preventing some potential jailbreak attempts as well. I think attempts to try to make
Yep.
it hallucinate more or spew more things that might not exactly be according to what the user basically is trying to put it through. So it's a very important thing to be able to prevent these kind of things, especially from an organizational perspective. And
Yep.
but yeah, I think that's really about all the time we have for this particular episode. So I hope that today's discussion has helped to simplify concepts like prompt engineering, vector databases, AI agents, and show you how they can fit seamlessly into different serverless workflows. And I'm sure that, Sandeep, I'm sure that your examples with Feedbackly has been able to bring a lot of good uh, knowledge as well to all of our listeners as well. And if you've enjoyed this episode, don't forget to subscribe, leave a review, and share it with others who might find it useful. And if you're curious about how to apply these concepts into your own projects, feel free to reach out to Sandeep directly as well. You can reach to him out at Sandeep Kumar P on LinkedIn, or to reach him at X or GitHub, you can reach him at Sandy Kumar 93. So
Yep.
again, that is Sandeep, Principal Solution Architect at Anstack, who has a passion of serverless architecture. And with that, we'll close up for now. Thank you again, everyone, for listening. And yeah, looking forward to the next one. Thank you as well, Sandeep.
Thank you, everyone. Thank you, Renaldi, for having me.
Thank you.
Bye.